What's up? It's been a while. Welcome back to my channel. For those who doesn't know me, I'm Riga. I post gudetama inspired lectures. For more information, you can search gudetama at Google. So in this video, we are going to learn about the molarity, which is one way of solving the concentration of a solution. Freezing point depression, which is one of the colligative properties of solutions, and the first law of thermodynamics. Molarity indicates the number of moles of solute per liter of solution. Molarity can be written in big letter M, which is molarity is equals to the number of moles of solute over the number of liters of solution. Example number 1. If there are 10 grams of sodium chloride dissolved in water to produce 2 liters of solution, what is the molarity of this solution? Now, basing on the formula, we already have the liters of solution. We will only need the number of moles of solute. Now, to get the number of moles of solute, we will need to divide the given gram by the molecular weight of the solute, which is 58.44 grams per mole. Now, using calculator, we will have 0.171 mole of sodium chloride. Again, with the formula, we will have to divide that by 2 liters, which is the number of liter of solution. Now, we will get 0.085, approximately 0.09 m, which is the molarity of the given solution. Colligative properties of solutions are properties that depend upon the concentration of solute molecules or ions, but not upon the identity of the solute. One of those is the freezing point depression. Freezing point depression measures the lowering of the freezing point of a solution. To solve the freezing point depression, we have the formula change in temperature is equals to IKFM. I is the number of particles of a solute. Now, it is always equals to 1 unless the solute is an ionic bond. Kf is the freezing point constant, while m is the molality of the solution. Now, to solve the molality, we have the formula molality is equals to moles of solute over the kilogram of solvent. Now, let us use that to our example number 2. 31.65 grams of sodium chloride is added to 220 ml of water at 34 degrees Celsius. How will this affect the freezing point of water? First, let's take the molarity of the solution. To get the moles of solute, we will need to divide 31.65 grams of sodium chloride with its molecular weight, which is 58.44 grams per mole. Now that will give us 0.542 moles. Next, to get the kilogram of solvent, we will need to multiply the volume with its density. Now take note that density of water at 35 degrees Celsius is 0.994 grams per milliliter. Now, using calculator, that will give us 0.219 kilograms. Let's take the molarity with the number of moles of solute and the kilogram of solvent that we found. So 0.542 over 0.219 is equals to 2.477. Now that is the molarity of our solution. Next, we get the I. Now, since sodium chloride is an ionic bond, our I is not equals to 1, but rather 2. For the two ions, sodium and chloride represents the I. Next, we have the freezing point constant, which is 1.86 degrees Celsius kilograms times mole. Now, using the 3, the I, Kf, and m, we multiply them. 2 times 1.86 degrees Celsius kilograms per mole times 2.477 mole per kilogram, that will give us 9.21 degrees Celsius. First law of thermodynamics states that energy can be converted from one form to another with a calculation of heat, work, and internal energy. It states that heat cannot be created nor destroyed under any circumstances. Mathematically, it is represented as delta U is equals to Q plus W. Delta U is the internal energy, Q is the heat change that enters and leaves the system, while W is the work that happens on the system. Now take note that work is positive when the work is done on the system and it is negative when it is done by the system. Heat change or Q is positive when it is endothermic or when heat enters the system. On the other hand, it is negative when it leaves the system or exothermic. Now let us apply that to our example number 3. A gas in the system has a constant pressure. The surrounding around the system lose 62 joules of heat and thus 474 joules of work onto the system. What is the internal energy of the system? The heat is positive because the heat is absorbed by the system. And the work is also positive because it is done onto the system. Now following the formula, heat plus work is equals to 62 joules plus 474 joules is equals to 536 joules. Now 536 joules is the amount of internal energy that has been occurring during heat change. Thank you for watching. Please subscribe, hit the notification bell, like the video for more.